Okay, students, now we consider what are the piezoelectric materials. Now we'll see pyroelectric materials. So piezo and pyro. Okay, so in piezoelectric materials, we have seen when you apply the pressure, polarization is created. Now in pyroelectric, you can just apply the heat and then electricity will be created. Dipolarizations will be created. Okay, so they are pyroelectric materials. And remember the difference between ferroelectric material, piezoelectric material, pyroelectric material. Okay. And when you are studying material, I told you have to remember characteristics, properties, and applications. So what are pyroelectric materials? So pyroelectric materials are piezoelectric materials. All pyroelectric materials are piezoelectric materials. Like we have seen difference between dielectric material and insulating materials. In dielectric materials, all dielectric materials are insulating material, but all insulating materials are not dielectric materials. So here, all pyroelectric materials are piezoelectric materials, but all piezoelectric materials will not be pyroelectric materials. All these statements you have to remember it. Okay. So it was discovered by 20th century by a Greek scientist. Okay. And the meaning of pyro in Greek is also heat. So the name pyroelectricity is derived from the Greek, where pyro means fire and electricity. Okay, so pyro means fire, or you can just remember pyro means heat, and electricity is created. It is general property of a certain crystal which are polarized to obtain large electric field. These pyroelectric materials are hard in nature and crystalline. Okay. So general property of the crystal that when you will apply heat, polarization will be created. You have just seen demonstration in the video also. Okay. So you have observed when dryer was taken near to that material, how multimeter shown you the deflections, change in the voltage, positive voltage, negative voltage. So that was the pyroelectric effect only. So pyroelectricity can be described as the ability of certain materials to generate a temporary voltage. Why temporary voltage? Because when heat will disappear, that voltage will also disappear. So it is a temporary voltage when they are heated or cooled. Reverse is also possible. When you are heating, you can see the polarization. When you are cooling, because cooling is also you are reducing heat energy. So reverse polarization in reverse direction you can observe. So the change in temperature modifies the position of the atom slightly within the crystal. So what is happening exactly inside the material? When you are applying heating or temperature, they will cause the changes in the atoms of positive, negative charges in the crystal structure, and therefore polarization will happen. Okay, and that polarization will change when you are going changing in the temperature. In this material also spontaneous polarization exists, but it changes with the application of it. I told you spontaneous polarization exists means without any force or without anything you will also see the polarization, and that also will change with the heat. So all these pyroelectric materials also will exhibit spontaneous polarization. Now, what is the difference comparison between pyro, ferro, piezoelectric metals? Now, try to understand. I already told you. Remember in comparison form. Okay, and then in Monday's lecture, test is there. So start preparing. Now, only one aspect: dielectric loss and tan delta, negative tan delta. Only half an hour job is remaining. Okay, so prepared for the test. 3 days holidays are there. So pyroelectric materials, ferroelectric materials, piezoelectric material. First point you write down the definition or the description. So in pyroelectric material which exhibits spontaneous polarization in absence of electric field. That is there. Spontaneous. Here also in ferroelectric material they exhibit spontaneous polarization. But piezoelectric materials they produce due electrical polarization due to mechanical strain or pressure. And this spontaneous polarization in pyro and ferroelectric material, it will change by application of heat, and in ferroelectric material that will changes its directions with the applied field. Okay, electric applied field. Now all pyroelectric materials are piezoelectric materials, but converse is not true. All ferroelectric materials are pyro and piezoelectric materials. and all piezoelectric materials are not pyroelectric materials. See, means here when you consider pyroelectric materials, they all pyroelectric materials are piezo. All pyro are piezo means this, but not pyro. And all pyro are this pyro also and piezo also. But piezoelectric materials are not pyro also. Pyro. Remember this. All pyroelectric materials are not pyroelectric. Widely used in infrared detectors. Ferroelectric we are using capacitors, and piezoelectric materials are widely used in transducers. Today we have seen it. And this type of ceramics, polycrystalline ferroelectric materials. Examples: sodium nitrate, lead titanate, then PB based materials, then layered perovskites. Then you can just remember this. Then semiconductors such as compounds of zinc and cadmium with OS, AC and T. So examples also you can remember. Now parameters. Here I am just showing you. You just name the points and then write down. So what is the function? Function of piezoelectric material: generate electrical energy whenever mechanical stress is applied. Pyroelectric material generates electric potential when heated or cooled. And ferroelectric metal exhibits electric polarization even in the absence of an electric field. And in the electric field, it will change it. We have seen that loop, okay, like hysteresis loop. So examples: quartz crystal, ammonium phosphate, quartz crystal, ammonium phosphate, lithium niobate, and barium titanate. Now examples are same for pyro and piezo, okay, but there will be different materials which are there apart from this. Then properties: this is non-centrosymmetric, so centers are not aligned. Then non-polar dielectric. Now we polar and non-polar, okay, so that we have also seen it. Presence of piezoelectric effect where P is equal to D sigma, okay. So presence of piezoelectric effect. Now in pyroelectric materials, they are unidirectional polarization. This only one direction polarization happens. Non-centrosymmetric. It exhibits pyroelectricity when temperature is greater than critical temperature, Tc. Then they are easily polarized when exhibit dielectric hysteresis. So we have seen that law. They are both pyro and piezoelectric in nature and applications. They are acting as a transducer used in microphones. It generates ultrasonic waves. Then pyro are used in IR detectors, image tubes, temperature sensing elements. And ferroelectric metals are used in ultrasonic transducers. They are pressure transducers also, acts as a memory devices like a random access memory. So this you have to remember it, applications, okay. So here temperature effect is shown, electric field produced is shown. These are dipoles, I told you, domains. The dipoles are originated in different fashions. So if you see resultant of this, the resultant will be zero. If resultant will be zero, no polarization will be there. And in some cases, resultant will not be zero. And when resultant will not be zero, then polarization exists. And that time you can call it as a spontaneous polarization. And when temperature will be applied, then changes will happen. So here it is shown that I have given you example in last lecture. What is shown here? If you will give temperature to such a materials whose domains are in similar directions, dipole moments are in similar directions. Now you just go on increasing temperature and this condition will happen. I told you, suppose you are sitting in a room and I will go on changing temperature. So initially you will just say whoosh, hush, then actions, and then different movements will start. Still I will go on increasing temperature. So these movements will start. Random movements will be there. So that is called as agitation, thermal agitation. Okay. So effect of temperature is producing the agitations, means nothing but you can say that this polarization will be also created. Okay. Electric field also will be created. So here pictorially effect of temperature is shown here. So you can see how the dipoles are there, positive negative displacement is there, and then electric field. So all these positive directions charges of the dipole moments are in this direction. So here positive plate is shown, okay, and here negative means negative. And when you are just giving electric field, then what will happen? So this is also shown that ammeter or multimeter. So you have seen in video, you just connect a multimeter or ammeter also, because if voltage is produced and then you will make connections of the two ends close, then current will also start flowing. Okay, so you will get indication that electricity is produced due to the applications of heat. So that is shown pictorially. Now watch this. Now why I am showing this? Why I am showing this? See, there are different courses. There are different courses of IIT NPTEL courses. So in activity number 13 or which you just check it, you can just complete the course. That is also your activity. So now you start searching material science related NPTEL courses or any, and you can complete that course. You can get it certificate. So that will be boosting up your CV. It will be very useful because company do see what extra activities you do, and that will also help you for the placement also, means as good as for your material science term work it will help you. Another things, your concepts will be cleared, and third things will be your CV will be built up. So start searching. Now I told you, you just tell me your activities. Three activities are compulsory and three activities are optional. So go through the syllabus and start searching yourself. Okay, and you tell me which activity you are doing. You choose that, yeah, I am going to do that certificate course. If it will be heavy, you tell me, then I will give you some things what we can do it. But you just finalize and tell me. Okay, so watch it. Now, when I'm showing video, no, you should not do only job of watching and hearing. Your fingers should go on writing the notes. So immediately you write down Pathshala, go on searching MHRD Pathshala, see which videos you are getting, see the syllabus, and just say that I will do that activity. Okay. See, students, so what I think, if I will go on talking like this, how much you will retain it? If PPT is there, there are two types of learners. One will just go on reading instead of hearing me, and one will just catch the sound. So there are different styles of learning. Try to find out your own learning styles that will help you. So some students are visionary. So if they will see the teacher, they can retain it more what teachers say. But somebody will just learn by miss reading on the PPT, and when some text materials are there. So nowadays you can just see whatever audio sounds are coming, text messages are also coming. So that helps sometimes catching the content. Okay. You try to analyze your learning style. Okay, so that was my intention of showing this video. Now see, I will just press it. Now stop.